Okay, so for this last video that's where a does not equal 1 and we have a trinomial, um, right now these numbers look absolutely terrible. If I went 60 times 15, I would have 900 over here, and that would be a really hard problem to work with. So like all the other factoring problems that came before this, we always want to look and make sure there isn't a greatest common factor that's making the problem more difficult. And in this case, that is the situation. So we'll look at 60, 65, and 15. 15 is probably the easiest of those numbers. It's 3 times 5. And once I see that 5, then I realize I can get a 5 out of the 60 and 65 as well. So let's get that factored out front. And that's actually going to make this a bunch easier. So 5 goes into 60 12 times. 5 goes into 65 13 times. And 5 goes into 15 3 times. And so now instead of 60 times 15 would be 900, I have 12 times 3, which is 36. So just getting that 5 out of the way takes this thing that's kind of next to impossible and makes it a pretty straightforward problem. So in this case, we're going to look for two numbers that multiply to be 36 and adds to be 13. And with that, hopefully you can see pretty easily the 4 times 9 there. And then, again, I'll show this both ways in this video. So we'll do AC first. 12x squared, and then plus 4x plus 9x plus 3. And when there's a greatest common factor like this is where I don't love AC method, just because it gets a little bit hard with the parentheses to kind of keep track of where you are. So what we're going to do is we're going to change to a bracket for that outside parenthesis to try to make it a little clearer. Looking at these first two terms, I could factor out a 4x. So let's do that first. And that'll give us a 3x plus 1. And out of these two terms, I can factor a 3. And that'll give us another 3x plus 1. And then this is our 4-term grouping, so we would take the 3x plus 1 out front. And it'll leave behind the 4x plus 3. And it's right in here where sometimes students get a little bit messed up in terms of kind of all those parentheses. Something you can also do mathematically, like it's not the best notation, but sometimes I'll just tell people, instead of using those parentheses, to draw themselves a little arrow from that 5 in front and then stop writing it for the next line or two, depending on how many lines that takes you, just to remind yourself to kind of put it back in there at the end. And so if I were rewriting this from here, oops, come back, Reeser. There we go. I would have just drawn a little arrow on the 5 to remind myself not to lose it, and then written this line like we have been, and then I'd write out 3x plus 1 and 4x plus 3, and then that's just to kind of help me remember to put the 5 in front. So that's kind of one little workaround to that messy line with the extra parentheses going on. For magic method, this would be, for that you can just write the 5 right where it is, so kind of picking up from here, and we'd have 12x plus 4 and 12x plus 9. Greatest common factor in there is a 4. Greatest common factor over here is a 3. 4 times 3, that's the extra 12 that I need to divide out. Oops, that didn't really help that 4. So this would be 4, and then 4 goes into 12, 3x plus 1, and 3 goes into 12, 4x plus 3. So again, whichever of those methods seems like it's working better for you, stick with that one. They both get you to the same spot.